Hello friend, welcome to Mechanical Concepts YouTube channel. Through this channel, we are providing n number of mechanical concepts at free of cost. So those concepts are useful for writing Public Service Commission examinations, railway exams and SSC exams. So if you want to get benefit from this, you just subscribe to our channel and press bell icon. Then you don't miss any video from us. So now let us start the concepts related to fluid mechanics. So first of all, we just see what is the difference between solid and liquid, solid and fluid. Okay, in this video we just see the difference between solid and fluid, the fundamental difference between solid and fluid. See what is solid and what is fluid. See, to differentiate solid from fluid, I want to take a help from force. So I will give the definition for solid and fluid with the help of a type of force type. And we are all aware that in solid mechanics we studied different types of forces like normal force and shear force, right? Again, normal force can be tensile or compressive. Okay, so normal force, you know about normal force and shear force. Now what I want to tell you that is what is the force, is which type of force is required to get a deformation in the fluid. If you want the motion in the fluid, which type of force is needed? Okay, for getting motion in the fluid, which type of force you needed? Answer is shear force. Answer is shear force. Okay, so shear force is primarily responsible for deformation in the fluid. Okay, right. Suppose right, let us see what is the difference between solid and liquid, or solid and liquid, right? See, suppose for example this is solid. If you apply force on a solid body, which is a type of shear force, then what will happen in that? Then you can see there is deformation in the body, there is change in shape in the body, there is a deformation in the body, right? This is the new position achieved after the application of shear force, right? This is the deformation, this is gamma, right? So if you apply a shear force on your body, then the body deform like this. So now how the shear force is related with the shear strain? Simple, shear stress is directly proportional to shear strain, and if you remove the proportionality constant, you will see tau equal to z into gamma, right? This is the shear stress, this is shear strain. Okay, shear stress is directly proportional to shear strain, and if you replace this proportionality symbol with g is rigidity modulus of elasticity, rigidity modulus of elasticity. Okay, now what will happen if you do the same thing on the fluid, right? If you take a fluid clutch, if you take a fluid something like this, right? If you apply a force on it, shear force, okay, what will happen in it? Simply, what will happen? See, in case of solids, this shear strain is a constant thing. This is not dynamic. What is meant by constant is this is not dynamic in nature. What it means dynamic? This shear strain does not change with respect to time, right? If you apply certain amount of shear force, you will get certain amount of shear strain. Then there is no doubt in it. If you apply certain amount of shear force, you will get certain amount of shear strain. This shear strain does not vary with time in case of solids. But in case of fluids, the scenario is different. If you apply shear force, okay, what will happen? If you apply shear force on it over a time period, if the time changes, the deformation in the fluid also changes. Okay, So as time progresses, the deformation also may change. Okay, so the deformation may not be constant with respect to time. So in case of fluids, what we write generally is shear stress is directly proportional to, right, directly proportional to dou u by dou y, right, or this shear stress is proportional to dou gamma by dou t, dou gamma by dou t. Shear stress is directly proportional to rate of shear strain. Rate of shear strain. This thing you will see Newton's law of viscosity. Okay, so as far as now, you just focus on this equation. Shear stress is directly proportional to rate of shear strain. Rate of shear strain. Okay, shear stress is directly proportional to rate of shear strain. So here shear strain is dynamic in nature. This shear strain is changing with respect to time. Okay, that is the concept about the difference between solid and fluid. Thank you.